Hello everyone, welcome to today's Novedge webinar, 3D reverse engineering of complex freeform shapes with Mesh2Surface. 3D scanning is becoming more and more popular and people want to convert this data into CAD models. The demand for 3D reverse engineering of scanned data is increasing every day. How difficult can converting STL meshes to CAD model be? Well, the newest Mesh2Surface provides proprietary state-of-the-art technologies which, combined with ease of use, delivers power not available even in high-end packages. In this webinar, you will see how to convert complex CAD shapes into professional CAD models. It is not about building from scratch, of course. It is about 3D reverse engineering. Now, let me tell you a little bit about our presenter. Kostadin is the product manager of Mesh2Surface, and he has been with the team since the beginning of 2010. He specializes in 3D scan processing, 3D scan algorithms, and product design. He was also a key member of the team who built the first handheld 3D laser scanners. Now, let me tell you a little bit about Novedge. Novedge is one of the largest online stores for design software. We offer a huge assortment of 3D solutions that cater to virtually every designer's needs. So check us out, novedge.com, and then you can search all the product you might think of for your 3D design. And I also want to remind you that we're on all the social media, you name them, Facebook, Twitter, Instagram. Stay up to date with specials, new releases, and follow us. And last but not least, I will be recording this webinar, so if you have to run off in the middle of it, you can pick up where you left on Vimeo and YouTube as early as this afternoon. Now, without further ado, I will share Costa's screen. Take it away, Costa.
Hello, everyone, and welcome to our webinar. Just a quick introduction, a couple of slides of who we are, which we presented in our previous webinar. Our company is a spin-off of Ada 3D, which is from Bulgaria, an experienced company for 3D scanning, data processing, and specialized for treating a large number of points. And we like reverse engineering. The company was founded back in '96 when we participated for the first handheld scanner, and we have a lot of experience in this. But we decided to put our efforts into the reverse engineering. In our previous webinar, we talked about the mechanical parts, how to convert them, but since then we put our efforts because there is a need to create much more sophisticated and complex shapes. As you can see on the screen, we have shapes in different industries, and we have been challenged how to handle them, what to do with them. Extracting primitives like planes and cylinders is an essential part of reverse engineering, but more and more people want to create many more complex parts. Which industries can benefit from this? Automotive, this industrial design, the entertainment, healthcare, any goods and shoes industry, all of them, they have forms which can be hardly handled by the traditional methods. Maybe most of you have visited our website and seen our gallery, but this is just a couple of examples what type of object we can do. For example, there can be parts in the automotive industries where we combine the perfect shapes, extracting cylinders where we can build a rim, but then we have complex shapes which can be hardly reverse engineered, or we can have purely organic shapes where we need to apply some different methods. And as you see on the screen, there are many, many examples out of this. So since then, we decided to create two types of products. One is the Mesh2Surface Mechanical, which people know up until now. And this product has all the basic features, but still powerful to recreate many of mechanical parts, complex forms. But then we created our premium version, which consists of more sophisticated and flexible tools to handle freeform shapes, which I'll make a demonstration in a couple of minutes. Again, I would like to say that our software is not a standalone currently. It is part of and it's a plugin integrated in Rhino. Why in Rhino? Because we choose to work very close to the CAD environment. We need to have this because when you reconstruct an object and convert it into a CAD model, then there is a need to process this further for the purposes of manufacturing, for the purposes of design, rendering, and many other ways. So staying closer to the CAD package is very important. Before I go to the live demonstration, I would like to say a few words of type of objects we identify during our observations and what the real world looks like. We have mechanical parts. They are purely designed of shapes like cylinders, planes, which can be extracted. And mainly when you create these accurate surfaces, then you can trim them and create these parts. After that, we have something which we call freeform trimmed surfaces. They are not defined with the primitives. They're still defined with the complex surfaces, but they are trimmed in the end. So, for example, this shoe heel is defined of a couple of surfaces. They are trimmed and they are filleted on the edges. And then we go to the other type of objects, which is completely freeform. What does it mean? Is that it's very difficult to create transition between the surfaces. You cannot define the surfaces like extrusion. You cannot define them as a revolved, but you need to apply a different approach. The next type of object we identify is a pure organic shapes. These are the parts which people scan from objects like clay models or heritage or bas-reliefs, all of them created by hand. For this type of objects, it's very difficult to apply primitives. It's very difficult to create surfaces that can so you can create transition between them, or it's very difficult job. And at the end, we have objects which can have really complex surfaces which are difficult to model, and then you have primitives, and then you need to trim them and build a shape together. So this was my very brief presentation about freeform. So I will just move now to the real. I will just start Rhino, where I'll just go through and show you what the features of our software for the purposes of freeform modeling. I just choose this example, which is a bike seat, and this file has been provided to us from Patrick Thorne, who is our partner in UK. So let's try to do some modeling on it. And as usual, we open this in our dedicated window. Before we start, we need to take a look and see what type of object this is. For example, if I take a look at the object, I see that it's actually symmetrical. If I turn on the coordinate system, I can assume now that it's purely symmetrical. So my goal will be at the moment just to model half of it, and then using the mirror tool in Mesh2Surface to recreate the full object. So This is I'm using the Mesh2Surface Premium, which is has our new shape, which is called quad surface. So I select this shape now, and like any other sub-D modeling package, we can have some tools which are understandable from everyone by creating just the shapes, and then you can manipulate them on the screen. Let's try a bit of the traditional approach in this case. So what I can do now is create a rectangular face. I just click on 2 points and I get this face. If I select a point, then I get the manipulator, or as it's called in Rhino, gumball, so I can move it around and just navigate and put it in space. I'll just put it in top view and try to manipulate with the gumball. The gumball has different options. You can create it as a screen oriented or local. The screen is however you move it, you see it on the screen always facing you, or local, which is perpendicular to the surface. Let's try to recreate something here. So I can select this, and holding Alt key, I can duplicate the edge. Then I can manipulate with the gumball. I can choose the point and move it in space. I put it on top view. And let's try to see how we can actually recreate this using this approach. So maybe I will just put it in front, I select, and then, okay, let's make it a bit more strict, so I use in the world. So this is how we work here. One important thing is how we visualize the mesh in our software. We have an option here, which is called offset, which actually displays the mesh just behind our surface, which we're trying to reconstruct. The other option which the user can choose is to be transparent. And again, with the slider, you can choose the transparency so you can get a better feeling how and where you stay. We cannot say which one is better, so it really depends on the complexity on the object, how you want to do the things. So it's a personal choice. Also, when you want to navigate these objects, you can choose how you want to play with the faces. So you can choose either to select only points, only edges, or you can select any point, edge, and face. In our software, we have something which is called pointed edges. I personally find that this is quite convenient and easy to use. So this is my favorite option. And this is how you approach with to adjust and recreate the new surface. I'll just duplicate this. Probably I selected the whole edge, that's why it was like this. So this is how you reconstruct and you do reverse engineering with the traditional approach. What we have now in Mesh2Surface is our new technology, which is called Snap Mode. This is something which gives a much better way for unprofessionals to do their reverse engineering. I will just delete my creation so far and we'll start from scratch. How do we do reverse engineering here? I just create something which is called four-sided face. I just click on the 4 points. And what the big difference is here, that the software always tries to keep all the points on the mesh. So whatever I do, the points are projected back to the surface. Here we have something which is called show duplicated handle. So this means that you can always hold Alt key and duplicate an edge here and start recreating your surface. But for ease of use, we just point to the D sign and then you just move around and it snaps. And this is how you start wrapping your surface. You can do this just by dragging and dropping and adjusting your shape. Continuing further, I would like to say that we have something which is called fixed neighbors. The reason for doing this is that sometimes, because of the spline theory, when you move a point in space, it actually influences all the points near, which are neighbors. But if you use this option, then the software tries to keep the neighbors fixed, so the user can only move the point which is point of interest. If we continue to reconstruct this, we can start wrapping around and build our surface. For the simplicity of use for the users, what we can do is when we duplicate an edge, if you move around, it highlights the points where it can snap. So you can snap a point here, then you can just drag and drop and it snaps here. Furthermore, if you want to make a bridge, you just take an edge here, move it, and it highlights that these two edges will be merged. And this is how you start and build your model. In the cases like this one, when you have a three-sided hole, the software cannot, as it is a quad surface, cannot fill this, so you can choose an edge, right-click, and just split this. In such a way, you create a four-sided hole, which you can either select by holding a Shift key and close the hole, or you just simply take one edge, drag it to the opposite side, and then you close it. In such a way, you can continue and build your surface just by dragging and dropping. One interesting option also here is that if you have an extraordinary point is a point which has on the boundary, but it has more than 3 edges. Then by holding Alt key, you can just drag and drop and just drop it in space. So it's really like drawing around the object. Another way to improve your shape is if you hold a Control Shift, we provide the interactive smoothing tool, which just by painting on the object, you can get the surface smooth. I would like to point out that during all these operations, everything just stays on the mesh. So whatever you do, the points are projected, and the software guarantees that all the points, all of your control points are actually on the mesh. Why we see these white and dark lines? The software, when you have faces during your building process, the software tries to create patches which will be actually a single surfaces. So this means that when we create a NURB surface, this will not be as many as the faces NURBs, but the software automatically tries to combine the surfaces. This means that in this case, we'll have only 3 surfaces. Why this is important? Because during the Boolean operations for the cut, it's vital to have surfaces that they don't join together, but you have one surface, and then all the Boolean operation works much faster. The file size is smaller. In such a way, I don't want to show you my design skills. We can reconstruct a surface like this one. So this is what we can get during our process of reconstruction. At any time, you can just press a space bar so you can see the smoothness of your results. Now, what can we do is actually to mirror our object. The way we do this is just by using our symmetry tool. We support symmetry and only on the main axis, as we find that normally people would align the object into the space and then this is not a big deal for now. So this is we found fair enough for the purposes of the reverse engineering. So by enabling the symmetry, the software creates mirrored points. So whatever you do from one side of the object, it actually influences the other. As you see now on the screen, this is a sharp edge, and something that we don't want. What we can do in this case is that we want to tell the software that all these points here, we would like them to be just to be smooth. So the way we do this is just by selecting an edge and telling the software that they have to be on the symmetry plane. The result of this is that we can create a nice and smooth surface. Let's move further to see how good we created our surface. For these purposes, we have something which is called tolerance option. Our real-time tolerancing is fast enough so it can show you in real time how well you're close to the surface. In this example, we see that this part is actually not lying on the surface properly. So what can we do now? We have an option which is called snap all to the mesh. The software tries to optimize and fit all the points to the mesh, but now we don't succeed because we have a symmetry, and this point and its mirrored point, they're trying to get as close as possible to the mesh, but it's impossible. So excuse me. So what can we do now is I can go and remove the symmetry, and the software at this point prompts me, do you want to keep this mirrored point? The user can choose, let's make a test now. I will just say, no, I don't want this mirrored point. So I can go back to my surface and say, snap all to the mesh. In this point, all my points will lie on the mesh. And if I want to improve my quality, I will just go and select an edge and split. Actually, I did increase resolution. I just split this particular one. Then I can improve by selecting this one, pressing S key, and this one. So the user in such a way can control the quality of its mesh, how close it can be to the surface. Please note that increasing the resolution will get close to the mesh, but it will actually capture all the defects and all the problems which will come from the inaccuracy of the scanner. So as you see, this will be my result. So if I go now and enable the symmetry, I will set all this to the symmetry plane. As you see now, my right side is very well placed on the surface, but my left side is not. And this is because this scan is not actually purely symmetrical. So here is the design intent. What do you want to do? Do you want to accept this purely symmetrical, or you want to get as close as possible to the surface? How can we do this? I just go back and we'll disable the symmetry. But at this point, I will just say that I want to keep my points. So now these points will become part of the object, but they are no longer, I'll just turn off the tolerancing. They are no longer actually symmetrical, so they are independent. And in this moment, I can just go and tell the software to snap all points to the mesh. So if you see now, the surface approximates much better the input mesh, but maybe it's not symmetrical anymore. So this is how our surface looks like, and it's ready to be created in Rhino. We can export by pressing the button Create in Rhino, and this is our surface. As you can see here, the software optimizes and tries to find the patches in such a way that the surfaces that are generated are not as many as the faces we have. I will go back to my surface, and yes, this is the part which was here. So I will now open another object, which is a half-scan part of the drill. And in this case, if we want to generate a surface like this one, the user may want to have nice and sharp edges here. The way we do this is just by selecting a couple of edges which will define our sharp edges. This happens by double-clicking on an edge. If we want to keep the same selection, I just hold the Shift key. And then I can just tell the software to make them crease. As you can see now, the continuity here is just G0, which means there is no smooth transition, and this is how we achieve the good quality. Another option which I would like to show you is another example like this one. This is a hybrid type of modeling where we want to have complex freeform shapes, but at the same time we have a cylindrical definition here. And how we can do this? I'll just take this again in Mesh2Surface, and I pre-created a little bit of this one of this part here. So in this case, what the advantage is that I will just create a new cylinder here, which will be used for our needs. The way we do this is just select a couple of faces and tell the software create a cylinder. Because this object is very well defined, I see it's on the origin, so I need to define that the cylinder is aligned to the z-axis and it goes through the origin. Based on the design intent, maybe the user may want to change the radius to make it accurate, but this is what my cylinder here is. So if I go back to my quad surface now, I would like to, which I modeled, I'll put it in transparent mode so you can see. I want to cut this, trim with this cylinder. So what I would do now is I will just switch off the snap-on mode and double click, and holding Control Alt will actually extend the surface actually will extrude the surface. Why we need this is just so we can trim properly with the cylinder. Of course, if the shape is not good enough, you can come and just tweak and adjust the surface a little bit. And then we are ready. I can create this surface in Rhino, then I can create a cylinder. So I will just demonstrate what we need to do here. I'll just take this one, edit trim, will trim the cylinder because I don't need it. But then I can take this part, edit trim, click the rest, and now we achieve what we wanted, nice and perfect shape, which is what is expected. Another way of using our freeform surfacing is when we have a very complex organic shapes like this one, where manual approach is not really applicable. So again, in Mesh2Surface, we just load it, and now instead of we'll just add quad surface, and now instead of drawing manually on the screen, we can just use our Autosurface option. Autosurface option has only very simple tool, and you can choose whether you want a low resolution or you can choose a medium resolution or fine. So the user gets a preview just with the hit of a button how the surface will look like. I can always press the space bar and just see my results. Also, I can see the deviation analyzer, so how close am I to the surface. And when I'm happy with my quality, then I can just accept my results. Now, the more faces you create, the more difficult it is, even if you have a most powerful computer. So how we can, for example, here we are not happy with the result. We offer just the simple tools where you can select and isolate this area, and then you can just drag and drop. I'll just enable snap mode because this is what I need. I just tweak a little bit so the software keeps the points on the mesh, and I can see my results. I can improve them. You can turn on the the shading and deviation, and you can improve your shape. So this is actually duplicates at the moment. It takes a while because the object is really complex, and it will create another edge which will come through the all the faces. Okay. Yes, it's a complicated part. That's why. It's actually stopped.
Yeah.
It happens.
Okay. Yeah.
I'll
It's
just
a beauty
continue in a minute.
Yeah, it's the beauty of being live.
So I will just load another example where the auto surfacing, it's easy and it makes sense. For example, purely organic shapes like this one. Again, I will just take it and put it in Mesh2Surface. Some people may just run Autosurface, but I'll just show you another flexibility, which we called wrap surface. The reason for having this type of functionality is that in some cases we have a cylindrical area like this one. So what we can do is just we take an area, we just mark it, and then if we go and just say create a wrap surface, the software automatically fits a cylinder, and then you can choose the resolution which you want, how good it should be, and then you can accept this, and then you can just tweak and adjust your quality of your results. Again, this is just a normal surface where you can create a deviation analyzer. You can improve your shape by just dragging and dropping on the mesh. Or if you want to improve the quality, you just select an edge and then press S key, and it automatically splits the whole chain of faces, and this is how you improve. The other option, which in this case is just to apply Autosurface. I choose this because it's a typical example where the user, it's really hard for the user to apply manual reverse engineering. So let's try the Autosurface. I just choose fine. And this is my result. Currently, the user, while he's here, he can just press the deviation analyzer and take a look at the results, how good they are. And if he's happy, he can accept. So this is the result of the bone. If the user is not happy enough with the resolution, he can always come and increase the resolution, which is a bit longer operation, which will take a while. Let's see how it will handle this. Yes, as you can see, we increased the resolution, which means that every face has been split, but at the end, when we generate a surfaces, this doesn't mean that it will generate more surfaces, but it will generate more control points. Well, when having more control points, we get more details about the object. As you can see, it approximates the surface in a much better way. So then I can create this in Rhino. Again, this is so I will just hide the mesh. I'll just hide the mesh, and this is my surface which has been generated. As you see, the software has tried to optimize, and it doesn't create the surface for every face, but it creates, it tries to build all the neighborhood faces into a single patch. And this is a valid NURB surface which can be trimmed, exported into IGS or step format or processed for any other needs. And the last thing I would like to show you is our helmet, which took a while manual to create, but we created from this object, we created this one. And I'll just open the mesh in Mesh2Surface so you can see how our network looks like. This is our quad surface, which we created by creating a symmetry here. We built a half of it, and we have a symmetry plane. We reconstructed this manually, and we created this. So I just generally showed you the main capabilities of the software. I would recommend if you can take a look more on the videos and training materials, but this is in general what we have in our latest version. So if you have any questions now, please.
Yes, we do have a couple of questions. Number one, are all freeform patches bicubic splines?
Yes, we use, it's based on the sub-D theory. So we use the sub-D technology and all the patches are reconstructed using cubic splines, which means that it's hard to tell that this is a Class A surfaces.
Cool. Okay, question number 2. What is the patch-to-patch continuity that is not at a crease? G1, C1, G2?
It's the continuity between patches. If I just zoom in here, continuity here is a G2, while at the extraordinary points, which had more than or different than 4 edges, it's a G1.
Great. And question number 3. Are files saved as a prep in Rhino or as a sub-D in Mesh2Surfaces?
Both. If I save this, as you can see on the screen, this was pre-saved files. This file is saved in our proprietary data storage, but at the moment we press create in Rhino, they are actually converted into a NURB surfaces. So this is not a sub-D anymore. This is a NURB surface.
Okay, that's pretty clear. And can Mesh2Surface make parametric models from point cloud?
Parametric modeling in Mesh2Surface is done in a way that we keep all our primitives here, so you can come anytime and modify your surface, which means it is a parametric modeling. It's not a pure parametric modeling, but we keep all the primitives created in Rhino, created in Mesh2Surface, and then at any point of time, user can come and modify the plane or the surface or the cylinder and reuse it again.
Okay, and the next question is if Mesh2Surface can export to other software than Rhino.
The current implementation of Mesh2Surface is that it's actually, in order to run Mesh2Surface, you need to have Rhino. So the way you can do this is when you finish your work, you just create the surface in Rhino, and then you take this, and then you can export into any formats you want, like IGES or STEP or not OBJ, but any other CAD file formats.
So you do have to have Rhino.
Yes.
Right. Okay. This is all for questions. That looks amazing, by the way, that helmet. I'll take my screen back. I'll keep an eye open for questions. So if you are thinking of last minute things to ask. And in the meantime, I want to show you again Mesh2Surface on the Novedge website. This is our catalog. You can choose all the configuration for the product that you like. It's very easy to navigate and to search. And we also do sell Rhino, by the way. And sorry, just a second, we just add another question, if you don't mind sticking around for a minute, Costa. As far as perfect straight, perfect round, can such features be exported to something like SolidWorks where they can be edited?
The way you export the results is using the most common format like IGES and STEP. If you want to edit, what do you want to edit? The shape itself, or you just want to export the freeform surface?
We're waiting for the answer. So John, if you can type it in so we can give you the shapes, cylinders, plane, etc. That's John's.
Yes, well, they can be exported as a IGES file format. We don't have direct connection to SolidWorks, unfortunately.
Okay, that's just Okay, and what version of Rhino would you need?
We support both Rhino 5 and Rhino 6.
Great, great. Okay, thank you so much. So you know where to find Mesh2Surface, and you know where to find Rhino or an upgrade to Rhino. We have the best price out there, guaranteed. I also want to remind you that you can find us on Facebook, Twitter, Instagram, where we post constant updates on new software and latest promotions. And I want to remind everybody that I've been recording this presentation, and I will be uploading it on YouTube and Vimeo later on today. Thanks again, Costa, and thanks for joining us today. Have a great rest of the day, everybody. Bye-bye.
Thank you.